Welcome back, folks. So we have another series here to evaluate. So in this scenario, we actually just need to evaluate. Well, we know what we're adding up. We're going from negative 12, adding negative 7, adding negative 2, adding 3, and so on. And our final term that we're adding is 223. Okay, so, well, again, let's just confirm that this actually is an arithmetic series before we do anything else. So from 12 to negative 7, we are adding 5. From 12 to negative 7 to negative 2, that's a difference of 5 more. And then negative 2 to positive 3, well, that's plus 5 more. Assuming this pattern works out and continues all the way, let's assume the person that wrote this problem did it correctly. This does look like it is an arithmetic series where its growth rate is 5. Okay, so again, we're going to need to know the first and the last term. Okay, well, we have that. So the first and the last term is negative 12 and 223. So when I add up all the pairs, they should all come out to, let's see, 223 minus 12, that's going to be 211. If I work my way inward, we'll get 218 minus 7 again to get 211. And so this in theory should keep going, again, assuming that this series was planned out correctly. Okay, so again, we know that the total sum, is equal to the number of pairs times the value of each pair. Again, that's always the value of each pair. That's always what this arithmetic series formula comes down to. The value of each pair. Okie dokie. Well, I know that the value of each pair, because they're all going to be the same, is 211. To figure out how many pairs there are, though, we're going to need to know how many terms there are, and just cut that in half. So, well, how many terms are there? Well, we don't know yet, but we could figure it out, right? So, I'm going to clean this up a tad. And again, we're going to have to start from somewhere. So, again, the easiest way is to just call the first term that you see term number 1. So, this 12 here, or negative 12, that's going to be A1. That would mean then that if this is A1, then this is 2, 3, 4, etc. This term, the last one, 223, that is going to be, we're going to call it AN. Okay? So N, in this case, N equals the number of terms. And so we just need to solve for N here, plug it into here, and then multiply that out, and we'll get an answer. Okay, so let's actually do this. Well, I can create an equation for A sub n because I know where the where the series starts and how it grows. So again, A sub n is going to be equal to A1 plus the common difference times n minus 1. So plugging in everything we have, A sub n, that's going to be equal to negative 12. Don't forget the negative sign there. Plus 5 times n minus 1. To figure out what n is then, well, we just need to plug in 223. So, well, okay, sorry. A little clarification. This is for n being any general term here. Okay? And in this case, this is n equals 1, n equals 2, n equals 3. So maybe I should have called this something else. Maybe I should have called this k. Oops, sorry. And therefore, we're looking for k. It doesn't really matter as long as we're careful. Okay, so again, we're going to say that A sub k is 223. And that's going to be equal to negative 12 plus 5 times k minus 1. We can solve this equation for k. So let's see, 223 plus 12. So add 12 to both sides, 235. Excuse me. And then we'll divide by 5. So let's see, divide by 5, this will be 47, I believe, equals k minus 1. And therefore, k is equal to 48. Okay. So let's actually do this now. So s is equal to 48, over 2. So that's 24 times 211. And I don't know what that is, but that's a number of some kind. Alrighty? And arguably, I would just say that was faster than doing all of this by hand. Alrighty. So I'm not going to evaluate that just because you don't need me to evaluate. You have a calculator. So hopefully that helped. And thanks for watching.